n. Here is the p-value for the overall f-test. Here are the coefficients, the intercept, and the slopes. Here is the p-value for the partial slopes. We'll use those to do the individual partial slope t-tests. Okay, and a lot of this other stuff is very informative, but some of them are building up to, for example, our p-value, and some of these are in order to calculate our p-values here, confidence intervals for our partial slopes, for our coefficients in general, and some more kind of multiple R, things we might have glossed over in class. Okay, so let me focus on what I've highlighted here, because that's what I've told you is important, at least on first pass. Here's R square. So obviously we got a very low R square here. This is saying that roughly 28% of the variability of Y can be explained by the entire set of independent variables that we've considered, which was x1, x2, and x3. Okay, so not the greatest output there for R square, not the greatest results, I should say, for R square, but that's sometimes in some fields that might not be the worst thing, so don't judge it too quickly. But obviously it would have been great to see a higher R square. That indicates some predictive power of our multiple regression model. Okay, adjusted R square, very similar, except it adjusts R square for the number of independent features used, independent variables used, and the sample size. So increase the sample size, you'll get better results. Increase the number of features, you'll pay a penalty. Okay, so as you see, R square is always going to be a little less than R square. Okay, in this case, quite a bit less. All right, and we use R square mostly to compare between models. Okay, so it's one way to compare between two models that are trying to predict the same dependent variable with a slight different subset of variables as the independents. Okay, so whenever you need to compare two models from the same data, I've shown you one method, and that is using adjusted R square. Higher indicates a better model. Okay, this is just our sample size. It seems we only had 23 observations. That's quite unfortunate. So that's N. Here, this is the p-value, although it doesn't get labeled p-value, for the overall f-test. Remember, HO, H1, the null hypothesis was that all the partial slopes, in this case there are 3 independent features, so all the partial slopes, there's 3 of them, are equal to 0. And the alternative is at least one of these guys, so at least one of those betas I've written above not equal to 0. Okay, for I equals 1, 2, 3, obviously. Okay, so at least one of these guys is not equal to 0. So what HO was saying is that there's no useful linear relationship between any of those 3 independent features and Y. What H1 is saying is that there is at least one useful linear relationship between at least one of the independent features and Y. It could be all of them. It could be just one. It could be 2. It could be a couple. There's different ways that it can happen. But this isn't. That's why we call this the overall test. Okay, because it does a lot at once. It doesn't tell you the details. If you reject this, in this case, p-value is 0.09. If alpha was 0.05, we would fail to reject. Okay. So in this case, we would fail to reject. So actually, there is not much evidence against this. Okay, that's what happens when you make up data. So if you fail to reject, which we do here because our p-value is 0.09, alpha is 0.05, then you would not go on to do the individual t-tests, which I'm about to describe. You would actually stop right there and throw out this model and reconsider the whole situation and what you want to do about it. But if we did reject HO, we would go on to do the individual t-tests, which the p-values are right here. Okay, so the t-test for beta 1, which is for x1, is, I'll just do one of these, is that the slope of x1, or we use 1 here, right, is equal to 0 versus it's not equal to 0. In other words, x1 has no significant linear relationship with y, and alternative x1 has some useful linear relationship with y, be it positive or negative. We look at the p-value, it's 0.09 again, which is greater than alpha 0.05. We would fail to reject, so x1 would not be a useful linear predictor. We might consider throwing it out of the model and rerunning the model. The same thing, except this becomes 2 for x2. Now, p-value is very high. We would definitely consider throwing out x2. We would fail to reject. And finally, x3, it's very close. We hate these situations, but it's very close. We would fail to reject if we were strictly adhering to our rule. If alpha was 0.05, this is slightly larger, so we would fail to reject. But it's pretty close. We would consider keeping x3. Okay, we would fail to reject there still, but it's very close. Okay, if you have to make a strict rule about it, you would fail to reject all these hypothesis tests. Okay, so it seems like there's nothing good coming out here, but you kind of expected that when we did the overall F test, right? Just to be complete, let's write out the regression model. Okay, so y hat, here I don't have a name for y, so it's y. Y hat equals the intercept. So let me just truncate and leave off the decimal places, but you shouldn't do that. So negative 85 plus 1.17 times x1 plus 0.07 times x2 plus, let me swing it around here, 0.49 times x3. This would be our regression model here. If you had actual names for these variables, which you should, you would put those names here instead of x1, 2, 3. If you had a name for y, like number of victories or price or temperature, then you would put that here, and make sure you put the hat. The hat will always remind you that this, and anyone interpreting your results, that this was a prediction. That this doesn't tell you what y is, it predicts what y is. Okay, so of course we left out a lot of details of some exploratory data analysis that you would do before you even jumped into all this, understanding the data, understanding that they were all numerical variables, and so on and so forth. I wanted to jump straight to the functionality of the data analysis tool pack and just show you highlights very quickly as I did the output that you'll need to.
So yeah, that's a good video on showing you how to do regression. I'm going to show you an example that I made up with a lot of the tools from that video. So these are the Coca-Cola statistics that I got from Yahoo Finance. So I'll go to data like he did in the video. I think let's change the location. So we use the Linus function for this. So we'll use Linus known y's. So these are known y's. So it must have been an update in Excel. And then the known x's, and then everything else. So we put commas. So we put commas between, and then we use shift to scroll down. So we have almost all of it so far. We'll just stick with the first few columns, and then let's run it. Too many arguments. Okay, so let's run it with like this. So I'll work on that and then I'll work on that and then get back to you on that. Just for some reason, it's not cooperating. But so doing scatter plots like he did in the video. So total revenue would be on the x-axis, the horizontal, and the cost of revenue would be in the vertical. So like we just label that. So axis title would be cost of revenue. And then the x-axis would be total revenue. So as you can see here, if we draw like a line of best fit for this, it would be as cost revenue goes up, total revenue goes up, basically. And then if you wanted to, that's exactly what would happen. And then like if you wanted to do a scatter plot with, let's say, so let's insert a scatter plot. So yeah, so we have this one. And then if you want to insert a scatter plot for this, we could put multiple on one axis. So yeah, we could do multiple on one axis. We could put all of them on one axis if we want. So let's try that. So we'll put the ball on. So yeah, you can put them all on, and then you'll have to just label it, putting down which one's which. So series 1 is like, let's say, cost and revenue. Another one's gross profit, and another one's selling, general, and administrative. So you can do that. Also, if you want to graph them next to each other with the 2D line graph, you can do that. So let's what you can do is let's say you take all of these. Might be too messy, but we'll try it. So like this. Yeah, it's too messy. So let's just try a few at a time. So let's graph all of these against total revenue. So yeah, the first one is cost. So let's label it. Right, well, so your cost of revenue would be the series one, and then like so, and then so on. Like it would be cost of revenue would be the highest, and then selling general administrative would be lower than that. So you can do that to for graphs for your report. So that's a good example of how to do a graph for your report. So I'll show you. We'll take our next activity. We'll just do some questions about some of what we've learned today already. Which bucket do you want to do this time? Yeah, sure. Yeah, I'll share those links. I'll put them. So I'll share them on Conestoga. So which bucket does everyone want to do?
Fishing frenzy.
Fishing frenzy. Okay, cool. So to log in, go into this link right here. So I'll post all the links for the videos.
With MailChimp, you can design beautiful marketing assets in no time at all, thanks to
Great job, everybody. Great job, Santiago. Great job, Jasmine. Great job, Ajit. Great job, everybody else. Thanks for all the participation. A lot of people participated. That's great. Excellent job, everybody.
No thanks.
Yeah, it's fun sound. So yeah, I figured out the.
Yeah, good job.
So here you can. There's an analyze data command on Excel. So you can take the data and let's say we can take all of the data. This is Coca-Cola's data like we did before. We take this, analyze the data, and then we can get this graph. So insert chart. So it shows that over time, a lot of like, you can see that total revenue. Over time, you can see the total revenue. It's influenced a lot by what happens with gross profit, like you can see here, and then not so much with interest expense because that's closer to the bottom, and then you see that cost of revenue is kind of going with what total revenue and gross profit are going, and then but total operating expenses are more in line with total revenue and gross profit in terms of the trends. And then income from continuing operations is more aligned with total revenue and gross profit. So that's a good graph. So you can explain in the report, you can explain about that. And then summing up cost of revenue, cost and gross profit there. And then doing a scatter plot showing that cost of revenue and net income are highly correlated. So you can show that, so they're very correlated. That's a good relationship to talk about. And then you can do, and then there's another graph here. Total revenue is highly determined by cost of revenue. And also you can look at, there's a lot of good charts here. So you can do a lot of good analysis of that for your report. Yeah, so Excel is a good tool to use for that. You can regress in Excel too. Linear regression is a good thing to do. You don't have to do it, but it's a good way to show how one variable influences another. I'm going to show, there's this other program, it's called R, that can be used to do linear regression. I'm going to show a video on that.
MailChimp's AI-powered creative assistant. It's pretty neat and kind of magical.
Hi, I'm Mike Marin, and in this video, we'll introduce simple linear regression using R. Simple linear regression is useful for examining or modeling the relationship between two numeric variables. Well, in fact, we can fit a simple linear regression using a categorical explanatory or X variable, but we'll save that topic for a later video. We will be working with the lung capacity data that was introduced earlier in this series of videos. I've already gone ahead and imported the data into R.
And I'm using RStudio. So I'll put this into the chat. Actually, I'll show you how, yeah, I'll put in the chat so we can download it. So RStudio. I'm in the chat right now. So yeah, the free version right here. I'll put a link to that in the project. So get a link. Keep running the video.
And attached it. We will model the relationship between age and lung capacity, with lung capacity being our outcome, dependent, or Y variable. We can begin by producing a scatter plot of the data, plotting age on the x-axis and lung capacity on the y-axis. And we'll add a title here. We may also want to go ahead and calculate Pearson's correlation between lung capacity and age. We can see that there's a positive, fairly linear association between age and lung capacity. We can fit a linear regression in R using the LM command. To access the help menu, you can type help and in brackets the name of the command, or simply place a question mark in front of the command name. Let's go ahead and fit a linear regression to this data and save it in the object MOD. To do so, we'll fit a linear model predicting lung capacity using the variable age. It's important to note here that the first variable we enter should be our Y variable, and the second variable the X variable. We can then ask for a summary of this model. Here we can see that we are returned a summary for the residuals or errors. We can see the estimate of the intercept, its standard error, as well as the test statistic and p-value for a hypothesis test that the intercept is 0. It's worth noting that a test if the intercept is 0 is often not of interest. We can also see the estimate of the slope for age, its standard error, and the test statistic and p-value for the hypothesis test that the slope equals 0. You'll also notice that stars are used to identify significant coefficients. Here we can see the residual standard error of 1.526, which is a measure of the variation of observations around the regression line. This is the same as the square root of the mean squared error, or root MSE. We can also see the R squared and the adjusted R squared, as well as the hypothesis test and p-value for a test that all of the coefficients in the model are 0. Recall in earlier videos, we saw the attributes command. Here we can ask for the attributes for our model, and this will let us know which particular attributes are stored in this object MOD. We can extract certain attributes using the $sign. For example, we may want to pull out the coefficients from our model. It's worth noting that we will only need to type COEF here, and R will know that these are the coefficients we're asking for. We may also extract certain attributes in the following way. Here we'll ask for the coefficients of our model. Now let's go ahead and produce that plot we had earlier. If we would like to add the regression line to this plot, we can do so using the AB line command. Here we would like to add the line for our regression model. And as we've seen earlier, we can add colors to this line, as well as change the line width using these commands. It's worth noting that we will need to do something slightly different to add regression lines for multiple linear regressions with multiple variables. We've already seen the COEF command to get our model coefficients. We can produce confidence intervals for these coefficients using the confint command. Here we'd like a confidence interval for our model coefficients. If we would like to change the level of confidence for these, we can do so using the level argument within the confint command. Here let's go ahead and have 99% confidence intervals. You'll recall that we can ask for a summary of the model using the summary command. We can also produce the ANOVA table for the linear regression model using the ANOVA command. Here we'd like the ANOVA table for this model. You'll note that this ANOVA table corresponds to the f-test presented in the last row of the linear regression summary. One final thing to note is that the residual standard error of 1.526 presented in the linear regression summary is the same as the square root of the mean squared error or mean squared residual from the ANOVA table. We can see if we take the square root of the 2.3, we get the same value as the residual standard error. The slight difference is due to rounding error. In the next video in this series, we'll discuss how to produce some regression diagnostic plots to examine the regression assumptions. These include residual plots and QQ plots, among a few others. Thanks for watching this video, and make sure to check out my other instructional videos.
Okay, so yeah, everybody, we'll take a 15-minute break. So we'll be back at 3:45, and then we'll finish. We'll do the rest of the material in the lecture. So just get a copy, eat something, but we'll be back at 3:45. So see you in 15 minutes, everybody. Everybody, so we're back. I'm gonna show, so I got a request about this during class time. I'm just gonna show you something. So I'm gonna show, this is not part of the course, but it's part of getting a job. So this is how I got this job. So I'll show you how I did. So what I did was, so a good strategy, what I recommend is go to college. So look up, let's say you want a job. Let's say you're looking for a talent acquisition technologist. So let's say you're looking for a technology job, right? So actually, let's say you're looking for just a general job. So you type in the search box talent acquisition. And let's say you want to work for Shoppers Drug Mart. So you connect with Ritika here. And then you press add a note. And it would be like, hi, Ritika. I am looking for a job in retail. I was wondering what the best steps are to get a job. Thank you. And then you press send. And let's say, so next, search. Says talent acquisition school. Say let's do this. So then, so Brad. So I'll say, hi Brad. I am currently a professor at Niagara and Conestoga. It's at Niagara College and Conestoga College. I was wondering if the professor was looking for candidates looking for teaching support right now. Thank you. Send. So you do that with, like, that's the best way to get a job. Yeah, doing it like that. So yeah, I highly recommend, that's the best way to get a job. So then I'll try one more just to show you again. So I recommend everybody wants to make a LinkedIn account just for jobs. Let's say, hi Carmen, I have a student that is looking to become a consultant. I was wondering if you were hiring interns currently from business programs. Thank you, Michael. Hi Carmen, I have a student that is looking to be a consultant. I was wondering if you were hiring interns currently from business programs. Thank you. So yeah, so you do that with a whole bunch of people and you get like 100 a week that you can message. So do it like that. I just wanted to show everybody that because it's very helpful because yeah, you can get a job out of it. So yeah, these so yeah, these ways of doing regression, like doing data analysis on Excel, you can use that in your report. Yeah, so these are good ways to analyze data. And then so now we will this type of graph is used to show the relative size of data or what part of each category contributes to the whole. Hint, it always totals 100%. So pie graph. And then identify the independent variable. If I change the amount of water in the tank, then the fish will live longer. So what's the independent variable for this?
The amount of water.
Yes, it's a great job, Santiago. Excellent job. And then what part of the scientific method is this? Distance ran by girls, 5 feet, 2 miles, 6 feet, 4 miles, 7 feet, 5 miles. Distance ran by boys, 2.5 miles, 9 feet, 7 miles, 8 feet, 3 miles, 10 feet.
Collection of data.
I'll give it to you. Good job. It's recorded data. And then what part of the scientific method is this conducted? Step 1, add sugar to water. Step 2, taste water. Step 3, record information.
Procedure.
Yeah, I'll give it to you. Good job. And then what part of the scientific method is this? If I add salt to the pancakes, then they will taste better. So hypothesis. And then what can be described as what I change?
Variable.
Yes, who is that?
Harold.
Oh, thanks, Charles. Great job. And then what are the 3 types of variables?
Dependent, independent, 2 are I know.
Uncontrolled.
Excellent job. Yeah.
Just
So the independent variable is what we're looking at to figure out if it influences the dependent variable. And the controls are put in. The reason why the controls are put in is because it reduces bias. That's why. Like it makes the result more accurate. So controls are like putting in, let's say, in my study that I did with the effect of ethnic diversity on political donations, I put controls for like income, education level, age, all those things, just so the result isn't biased. So that's what you usually have to do in a study. And then what would this be considered a testable question, true or false? How does the diameter of a container affect the height of a baking soda / vinegar reaction?
True.
Yes. Who was that?
Ajit.
Good job, Ajit. Yeah, excellent job. So yeah, you can do that. Like you can do a regression on that, or like a difference in difference thing. And then these two terms are used to determine the type of observations and collected data.
Research methods, maybe.
What did you say, Nisha?
Research method.
I'll give it to you. Good try. Good try. Thank you, Nidhi. Then when designing an experiment, these set of steps are called: 1, locate 2 puppies from the same litter that are similar in size. 2, feed one animal food with minerals for 1 month. 3, feed the other animal food without minerals for 1 month. And 4, calculate the average growth of each puppy.
Procedure.
Experiment.
Procedure.
Jasmine? Okay. Procedure. Good try, G. Then information that describes the quality/characteristics of observations and data.
Conclusion.
Qualitative. And then this type of graph is used to show data that is in some way connected, like how something changes over time or rate.
Bar graph.
Line graph. Then a scientific procedure undertaken to make a discovery, test a hypothesis, or demonstrate a known fact is a what?
Experiment.
Experiment.
Who said that?
He said it.
Two.
Fender and who else?
And Nana. N-A-N-A.
A-N-A? Okay, great.
N-A-N-E.
Oh, okay, sorry. N-A-N-E?
N-A.
Oh, can you spell it again? Sorry.
N-A-N-A.
Oh, okay, excellent. Sorry for that. Perfect. And then what is the dependent variable in this question? How does temperature affect the time it takes for mold to grow on bread?
So dependent variable is a term which remains constant in whole experiment.
Oh no, so
It is the length of time it takes for mold to grow.
yes. Who said that?
Jasmine.
Jasmine, good job. Good, Jasmine. So what happens is we're looking at, I'll give you, so we are looking at the effects of the independent variable on the dependent variable while holding everything else constant. So that's what we're doing. Yeah. Okay. And then which step of the scientific method do we want to use graphs?
Results.
Yes, who said that?
Conclusions.
Ajit.
Did you get? Good job. And then this is an example of, in class, Isabella notices the textbooks are thick with over 240 pages.
Observation.
Yeah, that sounds good. Who said that?
So two of us.
Pushpender and who
and-
else?
Jasmine.
Desmond, good job. Good job, both of you. It's great. And then what is a hypothesis?
Data.
Educated guess.
Thesis.
And then if small doses of calcium and magnesium are added to animal food, then the animal's growth will increase because calcium and magnesium are important minerals for growing. What's that?
Experiment.
So yeah, I'll give it to you. Hypothesis. And then what part of the scientific method has the purpose of the experiment, the hypothesis, evidence to accept or reject the hypothesis, and applies learned information to the real world?
Analysis of the results, I guess. Oh no, the conclusion for sure.
Conclusion.
A conclusion, yeah. Your choices, yeah. Good job, Divya. And then what step of the scientific method is this? Adding calcium and magnesium to the animal food did increase the animal's growth. The hypothesis is supported.
Procedure.
A conclusion. Then this graph is used to display data that fits into categories to compare information.
Bar graph.
Yeah, good job. And then what step of the scientific method is this? Does adding minerals to an animal's food affect the growth?
Problem. Experiment.
Experiment.
Was asked a question. Then what are all the things in an experiment that must be the same to make it fair or called?
Dependent variable.
Variable.
Hypothesis.
Controlled variables or constants. And then what skill is the scientist using when she listens to the sounds that whales make?
Observation.
Observation.
Yes, that's great. Then list the steps of the scientific method in order.
Asking question, observation, procedure, and conclusion.
Aim.
All. Excellent. So Jasmine won, but everyone else did very well. Good job, everybody. Excellent game. Yeah, we're proud of everybody. That's great. So next time. So I think we'll go through. So we'll go through this video. I'm just gonna put it up now. It's a really good one on. Also, we can use Google Sheets to do regression. So Google Sheets are free, which is a good thing. Like all you have to do is you go to So you go to, just type in Google Sheets, and then you can just create your own sheet. So we're able to do it on Google Sheets. So you go to blank and then you, yeah. So I will bring that up.
Robert, the board just approved the plan to build your sales team.
That's fantastic. And they can work from any.
Hi guys, in this video we're going to apply multiple regression to this data set. This is a data set that we saw in the Introduction to Multiple Regression lecture series, and we also saw output for this data set as far as multiple regression output was concerned. We created 2 models on this data, and we're going to go through all those calculations and computations using Google Sheets here, and I'll show you how we got all those numbers, and then you can go back and cross-reference and see that you get the same values that I get on this video, and that those values also equal the values that we looked at in the output in that lecture series. Okay, so just to remind you very quickly, this data set was concerning pie sales at a pie company. Okay, and we have a few variables to work with. So since we have more than 2 variables, this is called multivariate data. If you remember, we wanted to predict the pie sales, and we wanted to use some combination of the rest of these variables in order to predict pie sales. So right off the bat, we know we know that this is our y variable, and that the rest of these guys are at least potential predictors, potential independent variables that we can use. So in the first case, you recall I used price and advertisement in the first example. I didn't even discuss holiday until very later in the series of lectures. So let's just forget about holiday for now. Let's try to predict how many pies we're going to sell in a week using how much we charge, the price, and how much we spend on advertisement. Remember, advertisement it was in hundreds of dollars, so you could think of 3.3 as actually being 330. Okay, so we spent $330 this week, and we charged $5.50 for a pie. And in this particular week, we sold 350 pies. Okay, so that's one observation in this multivariate data set, and we have 15 observations if you count it. Okay. Also, one thing to point out, that this was a randomly selected 15 weeks. This is not in any special order here, in any chronological order. That's important because if it was in order, all of a sudden we have another problem called autocorrelation, which occurs when we collect data oftentimes over time. So we don't have that problem. These are 15 randomly selected weeks. Okay, so let us get the output for multiple regression, or let's run the multiple regression for this y variable and these 2 x's. So we go to add-ons, Excel Miner, and start. So if you don't have Excel Miner, you need to obviously install that one time, and it should go with you everywhere you go. Alright, so we're going to scroll down until we find linear regression. So this is the same linear regression that we used in simple linear regression. Okay. The y range is obviously our pie sales. Don't highlight the y variable and the name of the y variable. It'll confuse Excel Miner. Just one label is what it wants. Okay. Yeah, sorry. The x variable, there's actually 2 of them. So you need to make sure that they're next to each other. So in this case, since I'm only going to use these 2 guys, they're next to each other, that's fine. I don't need to do anything. But if one of them was here and the other one was here, and I wanted to use these 2, I would have to do some copy and pasting, cutting and pasting, and get them next to each other before I get to input their range. Okay, so I'm going to highlight these 2 guys. They're next to each other, no problem. Okay, I have labels, so I'm going to check that. I'm going to go ahead and uncheck confidence level just because I want to minimize the amount of output I get. Okay, now where do I want this output? Let me throw it right here so I can see it all on one screen, hopefully. Just make sure you have the right inputs. Y should be this column. X's should be these 2. Okay, check that yours is the same. And then labels, because I highlighted the labels. Okay, hit OK. When we started playing around a bit, I messed up the output range. Let me undo this and run this over. Okay, here we go. I was getting the right output, just I didn't want to overwrite my data. Okay, so look, we have a bunch of interesting things here, and if you recall quickly, let me just highlight some of these important stuff here. So I'm going to highlight R square adjusted since I'm until we find regression, or let's run the multiple regression for this y variable and these 2 x's. So we go to add-ons, Excel Miner, and
Everybody, I'm gonna just attempt what he has here. I'm just gonna send send this article. So these are the ones. This article I wrote was really funny. Yeah, but yeah, I'm gonna send this one to. And this one about how these ones are the best in my portfolio. And this is, yeah, if anyone wants to read any of this. And then this one's on jobs, like how to get a job. And then jobs. But yeah, then I'm just gonna attempt this here. I'm just gonna bring up add-ons. So the add-on that he was using it's called Excel Miner, and it's a tool pack. Excel Miner, there it is. Okay. So we gotta. So I'll show you how to get that add-on. So go to Mozilla here. Get add-ons. Type in Excel Miner analysis tool pack. So we'll get this one. Install. Continue. It's installed now. So go to extensions and then start. And then we'll have it on the side. So we can do, so this is how you can get you can get linear regression. So what I'm gonna do, I'm gonna take the data that we had from the other sheet. So the data for Coca-Cola. So I'll copy it. I'm gonna paste it. So we'll do input y range B1 to B5, so B2 to B5, and X range, let's do C2, C5. Wait, let's do, so X range, let's do all of it. We'll set, I think how to do this, we do C2 and then we go to I5 there. I'm just gonna go back to this video 1 second.
Start. So if you don't have Excel Miner, you need to obviously install that one time, and it should go with you everywhere you go. All right, so we're going to scroll down until we find linear regression. So this is the same linear regression that we used in simple linear regression. Okay. The Y range is obviously our pi sales. Don't highlight the Y variable and the name of the Y variable. It'll confuse Excel Miner. Just one label is what it wants. Okay. Yeah, sorry. The X variable, there's actually two of them. So you need to make sure that they're next to each other. So in this case, since I'm only going to use these two guys, they're next to each other, that's fine. I don't need to do anything. But if one of them was here and the other one was here, and I wanted to use these two, I would have to do some copy and pasting, cutting and pasting, and get them next to each other before I get to input their range. Okay, so I'm going to highlight these two guys. They're next to each other, no problem. Okay, I have labels, so I'm going to check that. I'm going to go ahead and uncheck confidence.
So I'll try what he has there. So then yeah, so I got the Y range there, and then the X range, I'll do the whole thing. So yeah, I got the X range, labels, and then I'll see what else he's providing.
Confidence level, just because I want to minimize the amount of output I get. Okay, now where do I want this output? Let me throw it right here so I can see it all in one screen.
So labels, no confidence interval, so just labels and then output range. Okay. So let's show that. Yeah. Let's put that okay here.
Screen, hopefully. Just make sure you have the right inputs. Y should be this column. X's should be these two. Okay. Check that yours is the same. And then labels, because I highlighted the labels. Okay. Hit OK. When we started playing around a bit, I messed up the output range. Let me undo this and run this over.
So yeah, turned out I messed up the output range, so I'm going to redo that. So the output range will be F10 now. Here you go. So we got it. So we got it. Figured it out. That's excellent. So I'm just gonna clear the sheet for a second. I'll redo it. It's a new spreadsheet. I'll bring the data back. I'm just gonna get the data again from Excel. And then paste it. So we have it here, and then we'll do extensions, Excel Miner Analysis Tool Pack. And then linear regression, labels, input Y range of total revenue for Coke. Got that now, and then this would be the X range. So we have the X range, and then let's put input F10. Output range F10. Okay. Try 11.
Okay, here we go. I was getting the right output, just I didn't want to overwrite my data. Okay.
So we'll try this again. For some reason, it's not working as well. Oh, there it is. Okay, good. So we got the graph. Like we got the chart. So yeah, in this case, like so to interpret this, like if we're gonna do an explanation for this, I'll show you how to interpret this information. So cost of revenue, we get this for cost of revenue, right? Probably. So in this case, $1 increase in cost of revenue. Just gonna double check with the data. So in this case, a $1 increase in the cost of revenue will increase revenue by $62,962.53. So that's how you interpret it, and then like a $1, so like costs, so then like if you're gonna do, in this case, a $1 increase in gross profit, increase in gross profit will increase revenue by 29,743.05. And then a $1 increase in selling, general, and administrative expenses will increase revenue by $39,108.16. So like this will be good for your report when you do write it. Yeah, you can use Google Sheets if you want, because it's free. Then a $1 increase in total operating expenses will increase revenue by decrease revenue because it's negative. Revenue by $69,332. So yeah, like it's great. Like you can use Google Sheets to do this. I'm gonna post this in the I'm gonna post this in the Google Classroom.
Brilliant helps you see math in a new way.
I'll post it under videos. So I'll put that under. That's how you do it there. So I'll put on a few more videos. There's like 2 more that we're gonna go through, but I'll
The scientific method is about ordinary people doing ordinary things. That includes you, me, and other scientists in the world. The scientific method is just a process or steps taken to produce reliable results to answer a specific question. Maybe you think you don't use a scientific method in your life, but I can guarantee that you do. For example, imagine you wake up on a Saturday and you couldn't find your cell phone. That's an observation. Then you do a little research by thinking about the last time you had it. You suspect that it might be in the pocket of your pants from yesterday. That's a hypothesis. And when you check your pants, you're doing an experiment. But science and life don't always go as planned, and you find no cell phone in your pants pocket. So the second observation leads you to think again and recall what else you did yesterday. You remember that you put your cell phone in your backpack during school. So you decide it must be there, and you go and check. And lo, there it is. Life can continue, and you're so happy that you share the results with your best friend and explain why it took you so long to text them back. Science. These are the steps of the scientific method. And at any step, you can go back and repeat the process. Typically, after you conduct an experiment and conclude that your results aren't answering the question, you go back and try something else. And really truly, Observations and research are going on the entire time. Science is a continually ongoing process. Now let's break down each of these steps into their component parts. All that can be observed with the 5 senses are included in observations. You use your sense of smell, sight, taste, touch, and hearing to make your observations in science. Research is an important step in science because it may answer other questions you have and help refine your experiment before you go down a path that leads to nowhere or conduct an experiment that's already been done. Make sure you use reliable sources to learn background information. Scientific journals and online sources that are vetted and trusted are best. Avoid information from blogs and out-of-date textbooks, as the information might not be reliable. Once you have your research completed, you can form your hypothesis, which is a prediction of what you believe will occur. It is often seen as an if-then statement and is very specific. Here's an example. If gummy bears are placed in water for 24 hours, then they will swell to over twice their original size. It has an if and a then, and uses specific terms that make this experiment repeatable. The experiment itself is made of several parts. Most experiments collect 2 types of data, qualitative and quantitative. Qualitative data relies on descriptions like soft, yellow, shiny, or wet. Quantitative data relies on numbers like 25 centimeters or 2.3 grams. Once you know what types of data you're going to collect, you can define the variables in your experiment. There is the independent variable, which is the thing you change to see how it affects your dependent variable, which is the thing you measure. So in the gummy bear example, the change in the experiment is that the gummy bears are being placed in water. The dependent variable is the volume of the gummy bear, which is measured before and after it's soaked in the water. A valid experiment will have both an experimental group, where the independent variable is altered, and a control group, which can be used to compare the experimental group to the normal or unaltered version. In the gummy bear experiment, the bears placed in water are the experimental group, and the dry gummy bears are the control, because that's how gummy bears normally are. So to summarize, an experiment should have an experimental group and a control group. The experimental group will have an independent variable and a dependent variable, and the data that is measured and collected can be qualitative, quantitative, or both. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe, and follow me on Twitter @SciencePet.
My job is to make college easier because students have a lot on their mind.
We're gonna watch another video. I'm just gonna put that on, the last video, and then we'll close it up for the day.
In this video, I will briefly describe the difference between deductive and inductive logic. I will also explain the connections between the two and show how both kinds of logic are important for knowledge production. In fact, they can be envisioned as integral parts of an overall cycle of research, as both connect theory with empirical observations. Deductive logic is sometimes referred to as a top-down approach because it starts with abstract theory, which we often envision as higher, and then moves to specific empirical observations. When researchers use deductive logic, they first start with a broad theory. They then articulate specific hypotheses to test that theory, and then systematically collect data by which they can test their hypotheses. If the data support the hypotheses, then the theory is also supported, but it's not proved either. If the data do not support the hypothesis, then the theory is not supported, but it's also not disproved. So for example, let's say that I have a theory that women are smarter than men. I would then need to generate some hypotheses or predictions to test that theory. Hypotheses are always stated as if-then statements. So I might say, if women are smarter than men, then they should have higher GPAs. I would then look at the GPAs at both women and men within a particular setting and see if there's a difference. This is my empirical observation. If women's GPAs were on average higher than men's, then my hypotheses or prediction would be supported, and that could then potentially also support my theory. Note that the data would not and cannot prove or disprove my theory. Instead, it can only support or not support my theory. So the goal here is to test theory. And to do this best, this usually involves statistical analysis in large numbers of cases. In contrast, inductive logic is sometimes referred to as bottom-up logic. Here, researchers start with making broad empirical observations. The goal here is to build theory, not to test it. Often, not always, inductive research involves qualitative data, so looking at a few cases with the eye towards deep, nuanced, and a meaningful understanding of those cases. So, for example, a researcher who is interested in student learning may observe students in classrooms and also talk with them after class about their experiences. The researcher may then begin to find patterns in terms of some students being more likely to participate in some classes than others. After collecting sufficient amount of empirical data, the researcher may then be able to start making some tentative hypotheses to explain these patterns. And from there, a theory of classroom engagement and success may begin to be built. In sum, when researchers use deductive logic, they first start with a broad theory and then articulate specific hypotheses to test that theory, and then systematically collect data by which they can test their hypotheses. When researchers use inductive logic, they start with observations and from there start to see patterns and from there start to develop theory. In truth, people are often using both kinds of logic simultaneously. We both come into situations with existing ideas about the world, and we also hopefully are open to collecting new information to then revise our existing ideas about the world. But it is important from a researcher perspective to be able to differentiate between the two in order to systematically evaluate the process by which we are making our conclusions.
So let's say you have to read an incredibly long email from.
So the video ended. So I think we're gonna close it out for today. But does anyone else have any other questions for today? Does anyone else have any other questions?
No, Professor.
Okay, excellent. Great job today, everybody. And email me if you have any questions. Yeah. Or WhatsApp, or send me a message on WhatsApp. And yeah, good job, everybody, today. And just reach out if you have any questions. And I'll see you next week. Take care, everybody.